Climate change is a statistical description of relevant quantities in terms of mean and variability over time scale ranging from months to thousands or millions of years. In Malaysia, a flood reveals the realities of climate change. Malaysia is particularly vulnerable to flood these days, with the frequency and severity of flooding events increasing in recent decades. For example, major floods have occurred in Klang Valley in the last 2 years compared to previous years, when floods were unusual. According to the United Nations, annual floods affects around 29,800 square kilometers of lands, home to 5 million people. Malaysia has an equatorial climate with high humidity and constant high temperature. The northeast and southwest monsoon have an impact on the climate. The former, which occurs between November and February, bring intense precipitation as much as 600 mm in 24 hours in extreme cases to Peninsula Malaysia's east coast, as well as Sabah and Sarawak. Rain-bearing wind comes with the southwest monsoon from April to September. True rainfall is often less during the northeast monsoon. In addition, there are two transitional periods in the monsoon when convectional thunderstorms are common. The annual rainfall in Malaysia has increased from the range of 1,691.8 mm to 5,320.8 mm in 2020 to the range of 1,589.2 mm to 5,365.8 mm in 2021, based on the Department of Statistics Malaysia Compendium of Environmental Statistics 2022. There are two basic types of rainfall causing flooding, which are first, moderate intensity with long duration rainfall covering a wide area, and second is high intensity with short duration localized rainfall. Furthermore, flood records shows that flood occurrences follow a seasonal trends. Floods mostly impact the east coast and southern parts of Peninsula Malaysia, Sabah and Sarawak from December to January, when the northeast monsoon is in effect. Flooding happens as a result of widespread extended heavy rainfall, resulting in a massive concentration of runoff that exceeds the capacity of streams and rivers. The west coast of Peninsula Malaysia, on the other hand, is primarily affected from September to November when convectional thunderstorms become common. Such storms bring short but very intense rainfall which severely overloads the drainage system, causing localized flash flood. The government's mitigation effort can be classified as structural and non-structural. Engineering approaches are used to solve the flooding problems under structural measures. To cope with excess runoff, river capacity can be increased through channel improvement. Construction of levees and embankments, flood bypasses, and construction of flood storage dams. Non-structural measures, on the other hand, are proposed where engineering methods are inapplicable or impractical, or when further measures are necessary. They include development restrictions, land use zoning, population resettlement, flood forecasting, and warning systems. In order to better handle future flood crises, we need to urge the government to improve its early warning systems. Furthermore, the parties involved must do more in terms of disaster planning and supporting sustainable development. Finally, develop frequent awareness campaigns and education activities to increase the understanding of environmental issues, especially on flash floods.